to find the true length of a line using the revolution method, right? This is the first one. First thing to do is to establish the x and y axis. I'll choose any distance. Then I would have to use the 10 millimeter. Okay. That's the 10 millimeter above the x and y axis. After obtaining the x and y and setting up the distance for drawing the front on the plan, I have to establish a line, construction line that is. I need to draw the front. I'll use a distance, I'll draw the front, and then this will be the plan. Because it's a line, I will set off a distance of, let me use 45. That's our limitation. And I want to use my compass to set a height of, I want my front to be of a height of, let me use 70. Let me use 60. So I use this point and I scribe 60. Okay, this is my front. That's my front. Now I need my plan, and my plan would be, I will use 55. Okay, 55, and I set at this point and I scribe. So this is front, plan. I need to label the points. 5 millimeter. It's construction lines that we're using. So this is A, point A, and the top is B. To the bottom, this is A prime, A1, and this is B1. Okay, so this is front elevation and this is plan. Now, one of the key things here is if I revolve about the front elevation, I will obtain the true length at the plan. So if I revolve on the front, true length would be obtained in the plan view. So I use my compass. I want to set at point A, open to B, and I want to scribe an arc to intersect the horizontal line that comes from A. So you see A, I have extended this line. That's where I want this arc to be. Construction lines only to that horizontal line. And this is a point that I will call P. I will extend this line. So this is a point I call P. P is this point. So what I do now is I use my set square. I want to extend P vertically downwards. Okay, extend vertically downwards. And then I want to extend B horizontally across. B prime horizontally across. Okay, so this is another point. This is called B2. Right? So now to obtain the true length of AB, I need to join A1 to B2. Okay, this is the line I want to darken. Okay, and this A1 B2 is the true length of AB. So what I do next is as follows. Below, I want to write draw guidelines first. Okay, and I want to write true length equals, and I will also want to write angle of inclination. Equal. Okay, so right now we're going to use our ruler. I want to measure this line A1 B2, and the length of the line is 65, 66, 67 millimeters. So you write 67. Okay, you do not need to write mm. I know it's millimeters. And then to obtain the angle of inclination would be this angle. Okay, the angle from this to that. Okay, this is the angle I am looking for. This is an unknown angle, so I want to use my protractor now, and I want to measure what is the angle of the inclination. And the angle of inclination here is and if you note, that is, this is the line. So we're talking about 20, 25, that's 20, 25, 26, 27, 28, 28 degrees. So the angle of inclination is 28 degrees. Okay, and then the last thing to do is to label here the x and the y axis. If you haven't darkened as I have, you need to darken. It's this one side. Okay, then you darken here to the top. X Okay, and this is the revolution method. All right, so now over this side I will use the same concept, the same line, but here we're going to do the opposite. Here I did revolve on front and obtain the true length on the plan. I would revolve the plan and obtain the true length here to the top. Okay, it's the other way around. So I will extend. Let me darken. I will use the same points here to the top. One of the advantages of this is, again, that when you have a T-square, you can simply extend these lines. Okay. The only thing left to do is to obtain the distance here, which before I had set at 45. So it is 45. That's a plan. As the front elevation. Alright? Points are labeled accordingly. All right, so now I want to revolve the plan. Oops, I did not label. So this once again is A, this is B, sorry about that. Right, so this is A prime and B prime. So I revolve about A prime, set at A, open to B, and I scribe until it touches this line. Only that line. Then from here I project vertically. I touch that horizontal from B. Okay. And to obtain the true length of the line is I project once again using the same guideline. Alright, and this is true length. equal, and here we see angle of inclination. Equal. So I want to measure first. $67. Angle of inclination. $30. What's the point? I get it this way better. I'm getting 34. The angle of inclination is 34 degrees. Okay, the angle of inclination for the line here is 34. The true length is 67. For the first, when I revolve the front, I obtain 67, and the angle of inclination is 28. Okay, so thank you very much guys for following.